In this video, we will be going over a tool to convert MATLAB to C. MATLAB is used for quick prototyping or testing of algorithms and math functions. Normally, conversion to C involves writing the C code manually based on the MATLAB implementation. The benefits of an automated process means saving labor and time spent on converting MATLAB to C manually, and if a change is made in MATLAB, then it's quickly repeatable. MATLAB provides a MATLAB coder to convert from MATLAB to C. However, there's no working open source equivalent. In our tool, we will be using TensorFlow's neural machine translation. The neural network we use for code conversion is a sequence-to-sequence model with two recurrent neural networks on either end. One of them is the encoder, which takes in an input sentence as a sequence of numbers. The decoder translates the sequence into the most likely target sentence, word by word. The decoder is aided by an attention mechanism, which gives the decoder context to the sentence being translated. Below, you can see the basic structure of the model. The encoder here takes in the sentence "I am a student" and encodes it into a sequence of numbers, and the decoder translates it to French. Here are two diagrams illustrating translation and attention. On the left, the diagram shows the process of translation given a trained model with source and target languages. "I am a student" is encoded into a sequence of numbers, and the decoder chooses the most likely target words denoted by the numbers in green. Here, the most likely target word is moi. Next, the most likely target word is suis. Note that, during training, these numbers are calculated by feeding in the correct target words alongside the source input. But during translation, the machine predicts based on these numbers. On the right, the diagram shows how the attention mechanism provides the context of the source sentence and influences the output translation. The next part will be a demonstration of the neural machine translator. We will walk through the training process and then demonstrate the tool's translation capabilities. In this video, I will be demonstrating TensorFlow's neural machine translator. The translator is used to translate natural languages such as Spanish to English. But in this video, we've extended the translator to be able to convert from MATLAB to C. The translator uses a sequence-to-sequence model, two recurrent neural networks on either side of the translator. One is called the encoder, and the other is called the decoder. The encoder turns the source language into a sequence of numbers, and the decoder uses that sequence of numbers to predict the most likely translation in the target language for that sentence. The decoder is assisted by an attention mechanism, which acts as a sort of memory that influences the translation based on all hidden states from the encoder, as opposed to only one hidden state. In short, the attention mechanism gives the decoder context to the sentence it's translating. Before running the translator, I will show how the training data is prepared. On the right, we have the original MATLAB code. And on the left is the C translation that I wrote myself. Now the comments will be removed automatically by script, so I did not change notation for those. But in terms of MATLAB-only operations and MATLAB notation, I've translated them into the closest approximation of C notation. In functions such as these, in statements such as these, where there are MATLAB-only ways to access the elements of an array, I have replaced it with C functions to mimic the MATLAB functionality. After translating the code, each file still needs to be pre-processed. The C needs to be tokenized, and the MATLAB needs to be tokenized, as well as special characters being replaced so that the translator can read the file. Here is the C data after it's been tokenized and processed. Here is MATLAB. Special symbols such as the equal sign have been replaced, the left round bracket, and so on. The same has been done to MATLAB. And after both files have been processed, they're combined into one file to use in training the translator. Here, the C code is on the left and the MATLAB equivalent is on the right. Now that I've shown the training data, I'm now going to run the translator that has been trained with the data I've shown you. And this is the output file that the translator has generated. It shows both the input and the predicted translation. But for the sake of readability, I've included a script to replace the placeholders with the original symbols. Here, in the input, you can see that the translator has been able to correctly translate this assignment statement. And here, it has been able to translate this equation, which is a MATLAB-only equation. And it was able to replace this notation with the function element-by-element division, and to modify the travel times variable with the transpose function. It is also able to read a for loop in the MATLAB notation and translate it to the C notation. The translator was able to convert these MATLAB statements to C statements, and with further training data, we can bring other statements to this level of accuracy. This has been a demonstration on the TensorFlow neural machine translator for the purposes of converting MATLAB to C.